and girls, fourth graders, thank you and welcome to your second and your final session of Science Club this year. Today you're going to be exploring the topic of rocketry. And I know some of you brought 2-liter bottles with you, some of you did not bring 2-liter bottles. It's okay, we have enough materials and supplies for everyone. That 2-liter plastic bottle is going to serve as a core cylinder for your, not solid rocket booster, but water rocket booster. And we've invited friends from the University of Rochester's Physics Club.
Hi guys, my name is Pam. Hi guys. So do you guys know about Newton's third law? Oh yeah, we have someone who knows about Newton's third law.
For every action, there is an equal and opposite reaction. So if you throw a rock up into the air, you're taking the force throwing it up. But then there's also gravity pushing it down.
That's a really good explanation. Basically, it's the force and the counterbalance force that is acting on the object. So for instance, I'm standing here right now, and the force that is acting on me, can someone tell me what's the force acting on me? Gravity? But if only I have gravity here, I'm just going to be pulling down through the earth, right? So I need something that counterbalances the gravity, which is the normal reaction force that's supporting me.
Her muscles are actually keeping her up. If she were to stop using the force of her muscles, what would happen to this fan? She'd fall right down to the ground.
Right.
So we're going to be designing rockets. Now, for your rocket, this is not going to be the top of your rocket. In fact, this is going to be the base of your rocket. What you'll be doing is you'll actually be working with a partner and with 2 bottles. And 1 bottle you're going to cut. Okay? You're going to trim this flat portion off, and you're going to use the top of 1 bottle, and you're going to attach it to the bottom of another bottle. I think do we have an example? That's a great shape for a rocket. Not very decorative, not very unique. So, materials. We have scissors to help, and there's adults to help you trim your bottles if you need that help. We have construction paper. What I'm going to ask you this time is to select a partner and find a workstation. I want to explain to you what you can expect to happen in about 5 to 10 minutes. You'll notice that our friends from the University of Rochester are feverishly working to assemble the launch station. What we have is, you'll notice that there's a cylinder going straight up in the air, it's white. Your rocket is actually going to be placed on top of that cylinder. It's going to be filled with water and it's going to be inserted on top of the launch pad. Well, if you follow that cylinder straight down, the white cylinder, it's going to be attached to that orange hose. That orange hose is attached to what? A pump, a bicycle pump. And what do bicycle pumps do? Yeah, they pump, they push air, pressurized, into an object. Maybe your bicycle tire. Well, in this case, it's going to be pressurizing the air inside your rocket bottle. So if you pump air down into the bottle, what should happen? The bottle should move, right? Should go away. Well, there's an actual trigger mechanism on the launch pad that's going to prevent the rocket from moving. So the idea is you're going to pump more and more pressure, more and more action into your bottle. All of that action, all of that reaction that's been built up, that equal and opposite reaction to go in the opposite direction, which is what direction? Up. The launch pad is not going to be operational here inside the building because, well, we're limited by a ceiling, correct? We're going to be going outside to launch our rockets.